Okay, very well, very well. So, good morning, all of the participants present here. So, today we are gonna continue to week 3 of this summer internship. I hope you guys are liking it so far. So, we are into like real physics in this current week. We build some technical skills before jumping into real hardcore physics. So, we are almost there. So, we covered basic command line interface, which is very helpful, and when you are gonna do parallel computing or when you are gonna do using supercomputer or cluster in the future, you will know why I trained you for command line interface, right? And then we touched Python. We developed like all the skills which is needed to do scientific calculations and plotting with pandas, like when we are manipulating data with pandas, which is very important. You don't have to go put yourself to tedious loop logics, right? Pandas are very imperative and very convenient. So we continued our discussion, our learning with Matplotlib, which is a powerful tool for plotting, right? You can see, you can just press one button and you can, it is very simple. The syntax in Python is very simple as compared to other plotting or other programming languages, right? For example, you might have used GNU plot or GNU plot. I found it tedious a bit, but Python is more friendly. So we are gonna continue our journey. We are gonna finish the Matplotlib session today. It's gonna last for around like 30 minutes, okay? And then we will be talking about where is my okay. So we will cover how to build a CV in LaTeX and how to do a Beamer presentation, which is very much required when you are going to present your presentation, like capstone presentation, in the last week of this internship. That is mandatory that you have to present it in LaTeX Beamer presentation, right? And then we have neutron star physics discussion scheduled for today, and the video I already shared. This is the video I was talking about, okay? So I was talking about this video. On the left side this is English, in the right side this is Punjabi, whichsoever you are comfortable with. Okay, so let's start with our session today. So let me open my VS Code and let me pin myself, maybe for everyone. Come on. Okay, good, cool. Okay guys, so let's start with our Matplotlib session part 2. So far we discussed various things like how to plot, how to use pandas with plotting and all those things, but we were mainly focused only on this single plots, like just one plot in a canvas, right? Today we are gonna learn like how to do subplots, right? And we are gonna learn how to save the output as a text, right? So you imported some file through pandas, but can you export it? Is this possible? Yes, you can do it, right? This is also possible. So we are gonna learn that, and then we are gonna learn very important thing, which is error handling in Python. I will tell you why it is important. Then we are gonna touch a little bit about scatter plots with annotation, color and size. I already discussed it, but I thought I didn't discuss it extensively, so I will put like 2-3 minutes on that. And then it's very important, I will share how to use subplots and how to use, you are familiar with Python, right? You can do wonders if you are, the power of programming languages, when you have a programming language and you are not dealing with some sort of interface like XMGrace or any other plotting softwares like Origin Pro. The power of coding is like whatever you can think in your mind, you can apply it in your code and you can do wonders, right? So we will take an example. We will be working on the example where we mix all the function, all the things we have learned, and we put it into a single plotting script, right? And then we have plot.subplots, obviously used for plotting subplots, like multiple plots within a canvas. And then we have we will learn functions, how to use function, how to put plot in the function and use it later for convenience. And then we also learn about argparse, which is very important if you want to optimize your code, if you want to make your code fast. Okay, you can control some variables from the terminal itself. You don't have to go inside your code and edit it all the time, right? We will learn that. It is very useful. Then at last we will be talking about the Seaborn library of Matplotlib. It is not a Matplotlib library but Python. Okay, so Seaborn, I will give you some default Seaborn example. So Seaborn is self sufficient in some way, like it doesn't have an extensive code. You just have to write 1 to 3 lines, that's it. So it is inbuilt kind of a function or library. Okay, so let's start with our first thing in the morning, which is saving output as a text or CSV. See, you can see you are familiar with all these things. I'm not going to repeat that. So we imported the required library for this particular script. Okay, then I loaded the data. I loaded the data using pandas, pd.read_csv, and this is the file name with the path, right? And I want to display the original columns. So how do I display? I can write, okay, print what variable I want to print. I want to print df.columns.toList. Okay, if I print that, I can see it is printing the original columns here. Okay, let me just mute this so that you can relate better. Okay, so it printed. Now if I am printing toList, it is displaying in some fancy way. I can just remove it, right? You know, Python is enormous. You can explore it. But if I am doing column, it is showing it like index, then there is a round bracket, then there are lists, and it is declaring it as object. Okay, so if you just do toList, then it will just display it like a normal original columns, no extra information. And then what I want to do is, I want to manipulate my file. I want to manipulate some of the columns of the file, and I want to add another column into my new data. So what I will do, I created a new column, okay, new data frame with column name total. So what it had previously, we can see that. So let me go to sample. What is the file name? sample_data.csv. Okay, so this is the file name. I put it here, right? Let us do side by side. Okay, so this is the file name. You can see it has some headers, and then this is the real data here. Okay, so what I want to do, it has 4 columns, 1 2 3 4. What I want to do, I want to create another column, another data frame with column name total, and I want to create by adding 2 columns, right? I picked one column study hours and one column exam scores. So it is just, do not find logic here. I just picked 2 columns to tell you. I cannot add study hours to exam score. I don't know. So the power of pandas is like it automatically understood that which index it has to sum, right? It will only sum 0 0 1 1 2 2. You don't have to provide any loop logic here, right? When you do that, it will sum the corresponding entries and it will put it here, df total. Now the question is, now I want it to save as a CSV, like comma separated value. Text is also lies within that domain. And what you have to do, you have to use this function df.to_csv. Then we have this whatever file name you want for your new file, and then this separator or delimiter. So here it is separator SCP. You can choose any separator you want, comma, space. If you want to show header or not, this is up to you. So let us see how does it looks like. So let me just print, and so it is just a display message, right? So let us just go and open my augmented text. Okay, it is a text file, so it will not open in a colorful way. Okay. So why it is opening in a colorful way? Because I have some CSV extension installed in my VS Code, or maybe it can read it by default. So this is the file I put. Okay, so what it has done, so initially it had like 4 columns, you can see 1 2 3 4, and now it has 1 2 3 4 5 6. Okay, why 6? 1 2 3 4 1 2 3 4 5 6. This is weird. Okay, so okay, let us not focus on that. So I can change the separator here to space. If I do that and I run this thing here, okay, you can see the spaces, the comma has turned into the space, right? And I can also do some other things. What I can do is I can remove the header none. Okay, if I do that, what it will do, it will print the header. Okay, now I have header. Oh, it is printing index, that's why it is 6. Okay, you can see there are 6 columns, 1 2 3 4 5, and this is the another one, it is printing index basically, that's why there is an extra 0 1 2 3 4 5 6 7 8. So we have 4 columns here, 1 2 3 4, which is this 146 80. Okay, and then we added a df total, which is the sum of this 2, and this is basically this guy here 41. Okay, and then we have study hours and exam score. Let us see. Study hour is 1, exam score is 40. It should be 41. Why it is 46? Yeah, it is 41. Okay, so this is how it is calculating. Now it added 45 plus 2 47, 50 plus 3 53. So it automatically added at the end. So how does it do that? It automatically does by this. You can also specify column, like which column you wanted to print here. So that is an exercise for you. Okay, so let us do index false, and let us do header none. I don't want headers. So when you do that, when index is false, it is not showing any index here. Now the first column is empty. So there should be 5 columns if we are adding the new column like df total. So you can see there are 5 columns now. So you can control the properties of the output file by using these options, right? So you can do that. You can also like you can ask me a question. So we don't have to define any column names in the Python file itself to the CSV file. We don't have to link that. Okay. For example, how does it know like df study hour is what? Which column is that? So the answer to this is, if the header is already defined in the CSV file, it will relate it automatically as long as the spelling matches, as long as the column name matches. It should be a case, it is case sensitive, right? But if there is no header in your input file, then you have to define your columns here separately using names or columns, use calls. Okay, so you can do that. So right now there is no need because it is already, the header is there, so the pandas can relate. Okay, so this is how you can export your data, right? And you can define the columns as well. So when you do that, let us see what happened. So when you do that, you define what columns you want to put in your output file. You can do that by using columns is equal to a list. How are you putting? Extract study hours there, extract exam hours there, then extract this guy here. So you can change your column, you can add one column here, you can subtract one column here, it's up to you, right? This is how you can generate a output file. Okay, so this is one thing I wanted to tell you. And then the next thing is error handling. Error handling in Python. Okay, so when you are dealing with the less extensive Python code, you take care of each line carefully, right? What is being written, what data it is reading, what column it is reading, you give your full attention. But when you are dealing with extensive code, your priority is not about okay whether the file is linked properly or not. You are more into the physics result, right? So when you want to do that, you might skip some trivial things. For example, the column name could be different in the header of the CSV, but in the Python script itself it is different, right? So there is a mismatch. If there is a mismatch, you will spend a lot of time to debug it. So there will be error obviously here, but it will be a lot to debug everything. So what we can do, we can use error handling in Python to avoid that. This is just one example. You can use this error handling thing anywhere you like. Okay. So sometimes your data might be missing or misaligned. Let's look at how to safely plot with try except blocks and handle common errors in scientific plotting. Okay. So what try and error or except is a form, like it works like a conditional statement, if else. So what I am telling my Python script to do, like try something, if it is successful execute this, right, whatever it is written here, and if it is not, show me the error. Okay, so that I can jump directly to the point where it was wrong. So the example is, I loaded a data frame. Okay, I loaded a data frame and I have assigned this column to some values, I declared the name of the column. So there are several ways to define data frame. I told you all the things. Now what I want to do, I want to plot this revenue column. Okay, but if you can see the spelling of revenue and spelling of like true revenue is missing, they are not matching. So there is a typo deliberately put there to show some example. And in the except case, you can see it is like except key error as E, and what is inside that, print f string column not found, and this is a variable E. So this is also an example of f string. F string is used whenever you want to display some variable's value inside your print statement. For example, you can ignore these icons. Okay. So for example, so if what Python will do here, it will try this. If it succeeded, it will just go through that, it will not go to this particular section. But if it fails, for example, it fails because there is no revenue, there is no revenue column. Okay, revenue column is there, but there is not revenue column. So what it will do, it will show some error. What it will do, key error as E, it will identify the error in this block and it will display that error here. So this is a variable, E, and there it is put in this curly braces because it is a variable. And whenever you want to display a variable within a print statement, then you use f string. If you don't put f string, it doesn't know whether it is a variable or not. Okay. So this is one example which some of you have already used, maybe Ria has used. Okay. So very good. And so you can see since there is a column mismatch, the name of the column, it is printing this, it is showing that okay, there is some error in your code and you have to check it. If we are not using try and except statement, this will be, it will be very hard to debug it. Because there will be many bugs and you will go through one by one and try to identify what went wrong. So whenever you are loading your data frame, make sure you are using try except. Okay, and I also started using it recently. It feels like extra work, but it is very useful. Okay, so far so good. Now another example, if we can talk about trial error handling, is this here. So again, this is simple. We have a try section here, and this is the body for the try, and this goes with all the thing, and you are familiar with all these things, like we have data, then we define a data frame, and we put it into df variable. This is a table, basically data frame, and what we are doing, we are using loop to print performances, right? So we are using lock function here, which is like giving us exactly the particular index within the for loop. Okay, so it is printing something, and this is also an example for f string. There are some variables like score is a variable and I plus 1 is I is a variable. So I is a variable, score is a variable. I want to print it into the print statement. That's why I am using f string. Okay, so what it is doing is, if there is no error in this body, like when we are Python is executing this particular section, there is no error, it will just print it. Okay, it will not go through this part. But if there is an error, as we discussed in the previous example, it will show the error. Okay, so this is one of the example. You are already familiar with for loop and the if else logic. You can break it, like how it is working. So I am not gonna discuss that today. Okay, next is scatter plot in Matplotlib. So scatter plot is similar to plt plot. The difference is, like in the plt plot you have a line, continuous line, but in scatter plot you have like particular points, and we can also merge them, like we can have scatter plot and line plot all together. So you just have to write plt for that. Okay, so we will discuss about it. So what we defined two lists. Okay, and we have two lists, and then we plotted x, we put y variable here, which is a list. We defined within the scatter function, we defined color, marker, alpha, label, edge color, line width. So let us understand this one by one. So what is this? This is x, our x column. Okay, and this is our y column. You can see x column study hour, y column exam scores. Color is blue, that's why it is blue. Marker is O, that's why it is round. And alpha tells us about the transparency of this thing. Okay, so I can put 1, then it is a maximum transparency. Okay, and similarly label is the corresponding label for that particular data set. For example, for this blue one, the label is score. If you want to put another plot here, you can choose a different label. And then we have a edge color, black. So edge color is the edge color of this particular pointer marker, right? And I can choose it to something else so that I can display it well. Okay, so this is the edge color, right? You can also control the size of it. And then there is a line width. You can also play with that. So you can also play with the line width of the edge color. So these are very, very important tools. And you can also do plt plot dot plot. Okay, see, it can read my mind like always. So I can do plt plot, and let us do this, and when I run this, it uses the same data, study hours, exam scores, but now this is a line plot. Okay, and I want to add a marker on it. I will just write marker, and I can also control marker or alpha. Okay, so why it is complaining? Invalid syntax, for perhaps you forgot a comma. Okay, it gave me some hints. So you can see now this is a scatter plus line plot. Okay, you can display both of the thing. You can change color of your line, you can change the line width of your line, you can do whatever you want, as long as you know the functions, right? So you don't have to remember. When you play with it again and again, you remember it. Okay, so this is how to use plt scatter. And then these things I think I have already discussed. There are some new things. For example, you can control the font size of that particular option, like title attribute, and x label, y label, you can control the font size. And in legend, you can also control where do you want to display your legend. For example, this is lock is location, right? You can write lower left or bottom left, maybe. Let us see. Okay, so this is lower left. Similarly, you can write lower right, lower upper right. Okay, you can do thing, and you can also do one more thing, which is best. So when you do best, it will show, it will use it memory and put it there where there is no overlap. It is not working very well here, which is a separate case. So when you put best, it will try to put it into a place where it will not overlap. Okay, this is the definition of best, but it is not exactly working here. What else? So let me put into lower left, it was good. And then you can also custom the, you can put it in custom XY position. You can do that, you can explore that. And then we have plot.x ticks. The ticks are basically these 1, 2, 3, 4, 5, 6, these ticks, x ticks, and these are y ticks. Okay, and you can also specify a limit if you just want to. Okay, let's discuss about ticks. If I want my ticks to be displayed after every 10 numbers, right, I can just mute it. If I mute it, then it will do automatically. But if I want to specify that, okay, I just want it after 10 points, then it will do that. The range is telling us 0 to range is creating a list which is 0 to 100 with step size 10, like 0, 10, 20, that thing. And then we have x limit, y limit, which is very simple. I don't want to show the full y limit. I can show, okay, just cut my plot at 50, then it will just cut it at 50. Okay, these are the very trivial things that you can explore. Okay, you can do x limit, y limit. You can also put mini ticks here. You can do whatever you want. So I wanted to show an example of f string here, which we already learned. So this is a variable, right? And I want to display in the title that it automatically understand how many number of points are there, right? One way is you count it manually and put it. The other way is using some variable which learn it from the data set itself. So what I did, I chose a particular list or data set column, and then I put the length function which tells me what is the length of this column, like how many number of elements are there, and using f strings I was able to do it, okay, which is f. So I can use f string with single quotes or double quotes, it doesn't matter. So this is one other example of f string. Now can I do some more manipulation? Can I do some more customization? Yes, I can do. I can, for particular data set, within a data set, for particular points I can choose some other property of that of those points, and for some other group of points I can choose some other property. For example, here I have used color and size different plots, different points. So you can see for first 4 points the color is different, for last 5 points the color is different. You can also control the transparency, you can control the size, marker size, you can do many things, because this you can customize it, right, because you are doing it in Python, because you are doing it in some programming language. So you can do whatever you want, you don't have to just dependent on the interface which has a limited options. Okay, so what we are doing, we created a list, again score multiplied by 2, and this is how you can write in for loop in just one line. For score in exam scores, okay, so exam score we already have from here, okay, from previous cell we already have. So I can just put it here so that we can relate. Okay, and so what we did, we have exam scores. So for score in exam score, like for each you get score in exam score, you have initialized a variable in exam scores. So what you are doing, you are multiplying by 2, you are creating a different list which is like 80, 90, 100, 110, 120, so on, right. Similarly, then you defined another list with name by name color, and you are telling Python that if the score, okay, whatever variable you have created, okay, if the score is less than 60, for example these points, then the color is red, and if the score is greater than 50, I mean else statement, not greater than, not less than 60, then choose these. Okay, and again I am looping over exam scores, and I have put some if else condition there. So this is how you can write your logic in just one line, right? You can also do that using 4-5 lines, but this is how you can do it, one line. So what it does, it created a list, right? We can print a list. So you can see what it has done. It has multiplied by 2 for all the exam score list. Okay, and similarly for colors, it gave me like first 4 is red. Why? Because we have sorted this using the if else statement. The next one is gray. Okay, right. So I will just mute it, and then I plotted. I used scatter plot, x column, y column, and s is my size. Okay, as is a shortcut where I can select my my sizes. Okay, and then we have C for colors. So C colors is just a list we have put into a new variable C. So now what it is doing is it is running the plot.scatter is running for all of the entry one by one. For example, 40 the index of first index of exam score, then first index of size, the first index of color, then it display this point, then similarly next, similarly next, similarly next, and all those things, right? This is how it is done, and these things we already discussed. And you can also control the size, I mean the size of the marker, which is marker size. The variable is marker size. Okay, let's go further. We are already in 9:50 a.m. So what about the subplots? So we so far have we have learned how to make a plot, in one figure, one canvas. But let us learn like how to create multiple plots in one figure, and to do that we need to use something called axis probably. Okay, and the function we will be using it, plot subplots. So how we have to do it? First of all, we have to define our figure, we have to design our canvas, because it is not just one, we have to put some other plots in that. So how do we do that? So this is how we do that. Figure comma ax is equal to plt.subplots is a function, and then you are defining how many rows are in your subplot. So I have 2 rows. Okay, and how many columns are there? I have 1 columns. And what is my figure size? My figure size is 8 by 6. It could be any units, right? So 8 by 6 is 8 is the width, 6 is the height, right? Width, height. Okay. Figure size. Okay. Now let me just write it here so that we don't forget. So we can check that. Let us decrease it like this. It will create a weird shape probably. Okay, so 2 is the width and 6 is the height. So we just confirmed it. Okay, so I put it there again, and now we have 3 lists. Just we want to do some plotting. Now how to plot? So obviously you have to tell Python that which one is your first plot, which one is your second plot. How do you do that? You should have to put some indexing, right? So the index, if we are using 1 column plot, the index is simple, just one index placeholder, which is ax0. ax0 is the first plot and ax1 is the second plot. Okay, it will use the hierarchy and put the information there. Now what I want to print is, I want to print x, I want to print y. So I choose one variable here, second variable here, x variable, y variable, then I use some options and printed it. When I printed it, it displayed it like that. Okay, it plotted the plot. Similarly, I wanted to make another plot, and this time this is my y axis, x axis is the same. Okay, and I choose some different marker, color is different, these things you are master now, and I use plot dot tight underscore layout, which helps me so that the plots are not overlapping or any other information is not overlapping. When I do that, I can see these two plots. Okay, fantastic. So this is how you do subplots when there is only one column or there is only one row. So this is an example of only one row. Now let us think about if we have like multiple columns, multiple rows. For example, in this case, so when we have correspondingly this plot, this case, like we have how many rows are there? We have 2 rows, 2 columns, right? And the figure size is 10,6. You can change your figure size to 10 by 10. It is up to you. How do you like it, right? So this is how do you, it really up to you. So I will just do 10,6. I like it. Okay. Now what we will do, first thing I wanted to tell you is, now since this is a multi-dimensional thing, the previous one was also multi-dimensional, but the one axis was fixed, but this time we have a kind of a matrices, right? This is like a 2 cross 2 matrices, 1 2 3 4, 0 0 0 1 1 0 1 1. Okay, so we, if we have to put some plot here, we have to be very careful about the indexing, and the indexing is controlled by this guy here, AXS. Okay, now this is not AX, this is AXS, this is the difference. And when we have AXS, we have 2 indices here which basically controls AX00, AX01, AX10, AXS, I wanted to say AXS11. Okay, so it is controlling like that. And this, all of the things are just Python list, how you manipulate the numpy, use like not numpy, we are not using numpy here, like how we are manipulating with different data, how we are using loop logic, how we are using loop within loop. Okay, so this is a classic example of where we are using so many functions of Python together to plot something. So what I will just give you one example here. Obviously when we have 2 indices, then we have to use 2 for loops, right? Because we are creating everything manually. For each I there will be a j. For each I is what, 0 to 1, and j is also 0 to 1. So how many permutations are there? 4 permutations, right? So for each I we will run all the j, and for the first I we will run all the j. For example, in this case, for first I range is 2, which is 0 1, we will run all the j. That's why it is indented within the for I block, and yeah, that's it. So if we have 3-dimensional, there could be another layer. Okay, and then we have this tight layout, again the same option. So what we are doing here is we are plotting AXS.plot, and what we are plotting is X Y list ID X. Okay, so why I am using a different indices in a already defined list? Why? What is Y underscore list? So Y underscore list, it has a function as well. Okay, let me go through that first. So in this case, I have also put function plot in a function. For what I have done is I have defined a function. Okay, within that function I have defined a plotting script. Okay, so how do I run this function? I just have to copy this part from here to here without the columns, and I can just paste it here. So this is how I can write a function. Now what I have to do, I have to provide the arguments to this function, so that the arguments goes here and it can execute this whole thing. Okay, so how can I do that? I have provided Y underscore list. So let us do that. Instead of putting it there, instead of putting this here like that, I made it easy. I just put it here. Okay, I just defined it here outside. So what it has done, so let's go through the variable. So we have X, which is a list. Okay, and then we have Y, which is a list, and we have titles, which is also a list. Okay, so make sure all of the list have same size. They are all like from 1 to 4. Number of elements should be same. And how I am creating y1, y2, y3, y4? It is simple. I am again using inline for loop. Like for I in x, create this list, like x is what, this the list will be what, 1 square, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So this number would be, see, this is smart, or it is multiplied by 2, not square. Okay, so this would be this, and similarly this would be this, and this would be this. Okay, so this is what we are generating through these lists. And when I put this list here, and what my create underscore subplot function will do, it will execute them line by line, and it will go through the all the indices, like it will go through, and then this IDX thing will come into picture. So what is IDX thing? How does the Python knows it has to relate which index to which subplot? How does it know? It will know with the help of this IDX. So I have defined a IDX, and I have looped it over so that it gets summed after every time. And when I do that, what will happen when I am executing? For example, let us say, let's start with I is equal to 0. When I is equal to 0, j is 0 or 1. Let's start with 0, 0 0 0 0. Okay, x is 0 0, that means I am talking about this plot, and then I want to plot it. I have list x, y list, and y list, the IDX is 0. What is y list IDX 0? Which is this y1. So it will plot y1 here, right? And similarly, for the next one, it has IDX is 1 because of the loop. Every time it executed a loop, it adds 1 there, and then we can go to the next particular subplot. Okay, so this is a bit tedious example for the new guys, new participants, but you can break this code apart, like line by line, do some print statements, then you will get to know why it is happening. And I will recommend you to add titles here, add y labels. Okay, I am just putting it as a comment. So the y labels are missing, you can see the y labels are missing, and x labels are also missing. Okay, so when you do x labels and y labels, you will be more understanding it, how this array indexing is working, how you are associating different array indices with different subplots. Okay, so far so good. So this is very important, guys. You will be using it a lot. Now how many things we have left? I have left like 2-3 things. And then what about that? There is another example of f strings. Okay, so again I am using a function. Okay, so I am using a function within a function. So I want to optimize my code again. I want to create my code with less number of lines. My end goal is I have an extensive code to build, but I don't want to repeat the things which are pretty obvious, right? I don't want to do that. So the number of lines in the code should be minimum. So what I have to do, if there is something very common which is common for all my different plots, so I have a plotting script which contains many plot, right, which contains maybe 6 plots in different functions, and each of the plot, these things are very common. I want to show the plot, I want to put some grids, I want to put some default settings. So what I did, I created a function, I put the common functionality, common plotting things in that particular function, and whenever I need it, I will just call it like that. Okay, so this is one thing, and I am using this inside a function. It doesn't matter as long as we are not using classes. So we will not use that thing here, which is not required. Okay, so I defined a function, obviously file path, some variables, some arguments, then created a data frame, and within the data frame I have used error handling that check if the columns x column is not in df column or I column is not in df column, then give me the error. That means it is reading the columns by default from the file itself, and we have not specified any delimiters, we have not specified any columns, because the columns are already there in the header. So, it can relate, right, it can just fetch the first column. But somehow if x col, whatever we are gonna define x column, so what is this is a variable and this is where we will put the x columns, right. So, when I put my x column as study hours, it will match with the df columns. How does the df column work? Df column will check the header of the file and it will check the name of the column, and if it is matching, it will fetch the data. If it is not matching, it will complain. Okay, let us do that thing. So, I manually tweaked it. So, it shows me key error. It is showing me that the key error is raise key error. Why it is showing it? Because I told my code, my script, that if column is not in df column, if x column is not in df column, then complain. If it is there, then do not complain. And this time I ran it, okay, and it is working fine. How do I know what is the what is in the df column? I can just print df columns, right. I do not want to specify it, it should pick it from the file itself. Why it is complaining? Cannot access it, it is not associated with the value. Okay, I am printing it a line before. Now it will not display because I am plotting. Come on, sometime it does weird stuff. DFF. It should work, but I don't know why whenever I am using plotting script, it doesn't execute the print statements. Okay, we have also seen that previously. So, I can show you the columns, right. So, what we have sample underscore data. So, you can see these are the column, it will try to match. Okay. So, this is how this is how you can use functions. Okay, you can give the file name here. So, why we are doing it? The reason we are doing it, sometimes we don't want our plotting scripts to be different. I don't want to write my 6 different plotting script for the 6 different plots. So, I just want to write my one plotting script. I want to change the variables from the function itself. I can do that. So, I can change my file path, I can change my file, I can change my column. If I do that, I can simply print a different plot, and I can also save it with a different file name. Okay, so this is the function. This is the power of using function within the plotting script. This is one utility. Now, again I will start with the thing that our main focus here is to use as less lines we can use for coding, right, we can use for plotting. So, I do not want to repeat the code. So, for example, in this case, if I have to plot for a different columns, what I have to do, I will copy this and I will paste this, or maybe for a different plot, yes, I will copy this and paste it, and I will change manually the columns here. So, this is one thing. Okay, but I do not want to do that. I do not want to write like 6 different piece of code to show my plots. So, I can just use functions. but I am still manipulating, I am still playing with my data, playing with my code inside the script, right. I have to go inside the script and change the arguments of the function. Is there any better way to do that? Can I control the plotting script, the variable of plotting script through the terminal? Can I do that? Yes, I can do that. There are two ways. One way is using bash script. Bash give you power, you can do whatever you want. We will talk about that in few days. Okay, I'm not covering that today, but I will just cover it, cover the argparse library of Python, so which gives us power to control the variable outside of the code. Okay, what do I mean? Let me show you. So this is this is a code written in code snippet, code cell. So this will not work here obviously, because this code, for this code I have to run it in the terminal, because I wanted to control some variables outside of the code itself. Okay, so it will not run in the Jupyter notebook. So a.py code is needed for this. What I am doing is, I will try to, first I will execute it and then we'll see. Okay, first of all I have, I think, created a file which is argparse example. Okay, this is a py file and I have written here how to execute this. So I will just copy it and I will just open my terminal. Okay, it's gonna complain, because this time I cannot just press this button, because when I press this button, what does it do? It basically execute the file python3 file name, whatever the file name is, .py. Okay, it does this thing. Okay, but when we are using argparse, we have to give some specific instructions to our code, right? How do we do that? First of all, let me see if I am in the same folder or not. So I am not, obviously I have to go to Python and then do ls, or now then do ls, and I am in plotting. Okay, then do ls. So if I do that, I am in the folder. Now I can just copy paste it. I copied it from here and I am pasting it here. When I do that, I have to change my file name, which is obviously, what is my file name? This argparse underscore example. So what file name I want to run is argparse underscore example. Okay, I can just copy it here and I update it here. So what I am telling my Python script is, let me just clear it so that you guys can see. So what I am doing is, okay, I have to copy again. Okay, so what I am telling my Python is, I have created some variables inside the Python script, which is file is a variable, x call is a variable, y call is a variable, right? So I am passing the values to variable. I am passing some values. So this sample underscore data dot csv is the value associated with file, and this is how we pass underscore hyphen hyphen x call, name of the variable, hyphen hyphen y call, which we have declared, variable is declared already inside the Python script, I will tell you, and this is the variable we are passing, the name of the variable. So when I do that, when I press enter, it is executing something. Okay, so this is one way. Now let us understand how it is happening. So let us see here. So we have imported argparse, and to do that we have to write some line, that we have to write that how Python will parse this information. We put some description and what arguments we want to parse. So we declared three variables under hyphen hyphen file, hyphen hyphen colon, x call, hyphen hyphen y call, and then type is string. What is the type of this variable which we are passing? It could be numeric, it could be string, it could be integer, it could be float, right? Whether it is required? Yes, it is required. Help is like for some description we want to add to the variable so that it helps with debugging. Okay, So now we define 3 variables, we pass this information, we declared three variable hyphen file hyphen xcall hyphen xcall ycall, and we associate it to some arguments, okay, and we will pass, and then we put a line which basically parse all this argument which gets this information and parse it or pass it to the Python codes below. Okay. Now what I am doing now, I am using this parsed information in my Python code itself. You can see data frame pd.read underscore csv, and now args.file, whatever values I have provided to this variable, I am putting it here. Okay, args.file, right? And similarly, I want to fetch information of my x column variable, args.xcall, args.ycall, whatever I want, wherever I want to use it. It is a string, right? So I will do that. So what is happening, again I will go to the right side. Okay, I press my first key. So this is normally like what we do. You can do Python 3. Then this is a variable you define, hyphen file, then you put the value whatever you wanted, hyphen xcall, sleep hours, hyphen ycall, exam score. It is similar to the previous example we were discussing in Jupyter Notebook. So when we do that, it went through all these things, it connected, and then it fetched all the values and it put in these variables. And since this is in the code, it should be in the codes, otherwise it will not work in the data frames and also in the file path. So this is how it works. Okay, so I will again put enter. Okay, now I want to change the name of the variable, so let's also do that. So for that I will need exam sample dot data csv. So study hour exam sleep hours, right? I have another column sleep hours which S and H capital. Okay, let's do that. So what I will do is sleep hours. Okay, so when I do that, it automatically understood the new column and it printed this plot for me, right? So this is not only helpful in plotting, it will be helpful in everything which you are interested in, for example doing some numeric, doing some data manipulation. So it is a very powerful tool where you can control your variables outside of the terminal itself. So I am going to repeat that thing again. This thing will not work in Jupyter Notebook because we have to define some variables in the command itself when we are executing Python, because when we hit this button, this is just Python, that particular cell. Now we have like 3 things remaining. I'm sorry, like I didn't think about it, will take a lot of time, but we are gonna finish Matplotlib and at the end you will feel happy. I believe so. Okay, now can we do 3D plotting in Matplotlib? Yes, we can do. It is very easy. It is very easy. There is a drawback in Jupyter Notebook when you do Matplotlib, 3D Matplotlib. You cannot interact with your output, right? So I will do that in a different file. So first of all, let us learn here. So I executed this and you can see this 3D plot here, right? It's 3D scatter plot. So 3D plots are mostly scattered, otherwise it is hard to see what is happening. So I loaded my data and then I defined a figure, plt.figure. So this time I am using this add underscore subplot 111, which is like 3-dimensional and projection is 3D. This is how you define your 3D plot. And then ax.scatter, and now I have to provide 3 data frame x, y and z. Okay, again I have to provide 3 labels x, y, z, title show. This is how it is done, very simple. And the most important part is this library, where basically you are importing Axis 3D from the library itself, which is MPL. Oh yeah, this is new. From something you are importing a library. Okay, and you can also define as a as something, so you don't have to do it right now. So let me just copy it, okay, and I will create a new file, okay, and I create a new Python file, I paste it here, and I will name it as 3D plot, okay. So I do that, and now it is a different file. I will just run it here. Why do I put it? Okay, so I run it, I simply press this button. So when I do that, it appears something like that. Now this is a 3D plot, I can interact with it, okay. This is very beautiful. So when you are gonna do with the 3D presentations, 3D analysis, data analysis, it is very important. You can see from whichever angles you like, okay. You can also manipulate your some of the settings. So this is very important, right? And you can see the angles here, and you can see x, y, z, everything. So this is very good. This is very simple, there is no fancy thing to learn here. Now I want to also show you a color bar plot. So I will do the same thing again. So new file, okay, Python file, and I saved it. Now this time I have color 3D, any meaningful name which I can remember later on. So I ran it. When I ran it, okay, it showed me something like this. Now there is a color bar on the right side, okay. Now the data, I can analyze my data more carefully, more visually. So what is the difference this time? Now we have 4 columns to interpret. These are not just 3 columns, we have 4 columns. The 4th column is in terms of color values. So we can see the color temperature and we can relate the values. It is hard to see. This is a scatter plot. When we have like put more information in that, you can see things better. So how do we do it? It is simple, the thing is same, all these things. The fancy thing, the different thing is gonna be this. We have 3 plots, 3 data frames, okay, and then we have this fourth column which we want to put in as a color map. C is equal to whatever data frame we are interested in, and there are some default color profiles which is known to be as the variable CMAP, and I have used weirdest, and you can search on Google, you can search anywhere, there are many. It just show different colors. And then we added a color bar. So this is just a map. If I want to add a color bar on the right side, so this is how I do it. I plot a color bar, okay, and I put this variable here so that it also plot the 3D, okay, and there are some options. You can play with it and you can see. You can try muting it, you can try changing the variables and see how the different output look like, okay. So this is color 3D.py. And at last we are almost there to the last cell. I can see happy faces, I can imagine happy faces of the participants. Last but not the least, introduction to Seaborn, which is used for static and statistical plotting. So how do we load that? We have to import Seaborn as an SNS, okay, and we have also we have to use Matplotlib, okay, because we will be using combination of it. So Seaborn is a library where you have like default sets. You don't have to construct the whole plot. See these are the outputs that I am talking about. So you can see this is just one line thing. So all these x, y axis, your scatter plot, all those things are already within this library Seaborn. So how are you doing it? So you loaded a default data set by using sns.load dataset, let us say tips, which is built in, and I printed it so that I know what is inside, okay. This is a table data frame with different columns and row, okay, and now I want to do scatter plot within Seaborn. So what I will do, I have to define my x column, I have to define my y column, I have to define my hue and data, what is the data source. So when I just execute this line, it created everything. I didn't have to define x label, y, did I define to? No, I didn't have to define x label, y label. It just put the information and put all the labels, everything by itself, and the only title I had to define, and then plt.show. Again, what about the box plot? If we are more into experimental particle physics, you need box plots, and you need some, have to show some uncertainties, and the data should be according to that, right? So the box plot is easy, x column, y column, data what you are using, when you just click a button and you get something like that. Okay, and the Seaborn can do it by itself. And heat map is also very important. So whenever you are trying to correlate with some different parameters within your model or any sort of coding problem you are having, you want to relate like how different parameters are associated with themselves. For example, total bill is associated with itself by 1, obviously the values are matching exactly. So the the diagonal columns will be same. So what we are trying to do is, we have a data and we want to relate this, how they are connected with each other, how strongly they are correlated to each other. So this correlation heat map is very important, and this is how you do it. I am not going to explore it, it is a bit advanced, I never used it, but I might use it in some problems in future. I got an idea. There is also contour plots, you can explore that, which might be useful for you, right? Yes. Okay, so far I guess this was about Matplotlib, and I hope you like this session. I suppose it to be 30 minutes, but it went around 1 hour and 10 minutes. Yeah, so that was it. So how was it, guys? Do you have any question for that? Whatever we did today so far? No? Hands down? If you don't have any question, please do hands down, otherwise do hands up. Thank you. Okay. Very good. So I'm gonna upload this session. Let me stop this recording so that I have a different video.